In this video, we are going to learn hash set in Java. Basically, we are going to implement our own hash set. Hash set is already available as a built-in data type in Java. In this video, I am going to implement myself a hash set for learning the algorithm. So let us start reading the documentation for the hash set in Java. This class implements a set interface backed by a hash table, actually a HashMap instance. It's very important. Uh, it uses Java hashset uses a HashMap instance. What does that mean? Let us check it. If you open the Java any editor, currently I'm using IntelliJ IDE. Type hashset, and you can click that one hashset, and here you can see that this hashset class, and inside you can see that they use a HashMap actually. So HashMap actually contains a key value pair, but in hash set we know that this is accepting only key. Hash set contains elements. Basically, that is a key. So what would be the value for hash set if they are using HashMap under the hood? So you can see here HashMap. They are using type of the key here, but here it is written like they are using object as a value for underlying HashMap. So let's go down and check it. What is happening at the time of hash set add? Yeah, here you can see they are using that HashMap and putting present is the value they are sending. So a constant they are using a present. What is a present? So present is just initializing an object, an empty object, and passing that one. So this is what they return here. Actually, a HashMap instance. So obviously you can see that one. It's a little bit inefficient, right? Because you are unnecessarily saving object for every hash set key. This maybe they have implemented like this maintenance purpose or something, or maybe they already implemented HashMap. They thought maybe we can use the existing code or something like that, whatever it is. Let's continue this. It makes no guarantee as to the iteration order of the set. So when you're iterating that one, they doesn't guarantee any order. It does not guarantee that the order will remain constant over time. This class permits a null element. This class offers constant time performance for the basic operations. It's very important. Constant time. So time complexity is constant for the basic operations. Basic operations means adding to the set, removing from the set, checking the existence of an item in the set, and size. Constant time. So we need when we implement this, we should make sure that these basic operations are in constant time. Assuming the hash function disperses the elements properly among the buckets, we use actually a bucket under the hood. So let us check in the here. Yeah, we basically in Java hash set we are using HashMap. I will go to HashMap. Here we can see bucket. I think this is the bucket, a key value pair. You can see that may be initialized in the capacity. Where is the initialization for the bucket? Capacity, we need to search for the capacity. Search for the capacity. Yeah, in the buckets this capacity. I don't know where that is initially is happening. Okay, anyway, I'm not, I don't want to spend more time here. Anyway, we are using some bucket under the hood in which all the keys are stored. Basically, it's a bucket is an array, and element of that array is linked list actually. Bucket is an array, and element of that bucket, each element in that bucket is linked list. The reason is that one, since it is an array, it contains index 1 to size of the bucket -1. So whenever we are adding some items, that item might not have a numerical value as a key. So we will convert to numerical value, and the numerical value may be out of the bucket size. So we need to use some modular operation to get inside that valid array indexes. Because of that one, more than one key can have same bucket index, array index. So basically one array element, one array place can contain multiple elements. For that purpose we use storing linked list. Iterating over this set requires time proportional to the sum of hash set instance size, the number of elements, plus the capacity of the backing HashMap instance, the number of buckets. Thus, it's very important not to set the initial capacity too high or the load factor too low if iteration performance is important. Note that this implementation is not synchronized if multiple thread success. Let me skip that one. Okay, that's all right now I'm doing. What I'm doing is that one, I will create a bucket and I will try to implement add, remove, contain, and size. Okay, it's a hash set in Java. We'll do one thing. I will create a new Java class. First, we want to store my hash map. I will remove this one. So basically what I will do is that when I will extend set. I think we need to install implement several methods. So I'm not going to implement all this method. I just can I remove any of this? I can't. I can't remove it. What is this issue? Okay, I will implement here. No interface. Okay, it's implement here. Okay, everything's fine because that's an interface. Can I remove one now? Yeah, I can remove. I don't know how many methods are required here. open action. Not sure how many methods are important there. Size is important. I don't know. Maybe everything important. So I'm not going to implement everything, but I will implement the basic operations like add, remove, contains, and size. Okay. First, I will implement add. I will implement this one. So we need to make it constant time. So first we need an entry for this hash map. My hash map entry we need to create. We need to create one. Basically we have a bucket which contains. We need to create a array. Need to define the buckets. The type of bucket is I will use a linked list. This is the bucket we create. Buckets and we need constructor. We need here empty constructor is there, initial capacity constructor is there, initial capacity and load factor. I'm not going to implement the load factor. Initial capacity is there. Okay, I will do one thing. I will public static int default capacity. What's the default capacity? They didn't write. I don't care that. Default capacity I will add 16 now here. I'm going to implement a constructor. Capacity. Why it is not showing any messages? The capacity. I'm not going to use private here. Type private. Okay. I will implement another constructor. It's empty and it will call, I think super is the keyword in Java, right? No, not super. I think this only. It will go here. Okay. So basically I'm implemented a hash set to these two things. And the next is that I need to initialize, if I get the capacity, I need to initialize this linked list. Buckets, new linked list, capacity. I use this capacity. Yeah, initialize that linked list. Basically, we have buckets which holds a linked list. Okay, so we implemented okay, now we need to add. Yeah, what is a hash map? Oh, E is the type. Okay. Yeah, we need to come up with what is the element we are storing in the linked list. That's the my hash map entry. I will define new Java class my hash map entry, in which I store only one int no string key, or string we want any other type e key. That's it. I will implement getter and setter, generate getter and setter, and we need a generate constructor also. Constructor, yeah, passing key. Yeah, fine. So this is the element we are going to store in our set my hash map entry, which contains only one element. And here linked list E. Okay. Done everything. I will try now my hash map. My hash map entry, key is a string, my hash map entry new my hash map entry. Okay, I think it is too big. Not my hash map entry, it's actually my hash map. Okay, now I will print the size. Hash map get size. What is this error is coming? A required size is a string, and okay, I will add some string, and okay, now I will run that, just checking whether everything is okay or not. Yeah, 0 came. It's fine, everything is fine. So this is my hash map we created, which accepts it's a generic type E, and based on that we will create a linked an array of linked list, because when we create the hash map we will tell the capacity of hash map. It's a fixed size actually, but we will dynamically grow that one, but the item we are adding have a key other than an integer can have. So because of that one, multiple key can be mapped to same bucket index, array index, because array index is an integers, so we need to convert element to some numbers. If it is a string, we need to find out some number for particular string. There are various ways to find a number for a particular string. It can be size of the string, or integer of the first character, whatever it is, you need to come up with that one. So we'll get a number that number can have multiple string associated with that. So you can't store in an array. So you need to use array of linked list, because in linked list you can store multiple values. In array you can store only one values. So that's why you used array of linked list here. Okay, now let us implement add. So basically we want to find out first we want to find out bucket index. If you get a element e, you need to find a bucket index. How you will find bucket index? E dot get E is actually a very generic, so you can't use okay, you can't use that one. Get key. What is this hash code in Java? Basically we want some hash code for this particular. Here we want to get we got an element, we want to get a hash code. Yeah, hash code is there. This is the default hash code. Let it be there. Yeah, I will do one thing. I will implement hash code here. Public integer hash code. Override. Return 1. What is the method? I will go here. I will click this one. Public int entrance candidate. What is it? Public boolean equal object indicate whether some of the other object is equal to twice. This method. It is not a part of the. It's not an interface or something, so you can't do that. You can write like this. I do one thing. This key dot. What is this key? Oh, that also not a string actually. Okay, I will do one thing. I will use this dot key or hash code. I think it's a capital C. Basically, when you are using like this, it will go to entry and it will execute this one, and it will find out the hash code of that key, because the hash code is defined in the object level, and if it is a string, it will string actually had a hash code that will return that whatever it is. We will get automatically hash code here. Then we need to do the modulo for this dot capacity, so that it will map to the range of index of the bucket. We got that one. Now we need to check we need to get the linked list E and bucket entry bucket entry. This is actually head of the linked list. I think here this is not required actually. Bucket index we got. Basically I'm going to add, and I'm checking whether first I'm finding out the corresponding index of that key, then I'm getting the bucket entry and checking if bucket entry is null. If there is no linked list for that particular, then what I will do is that one bucket entry equal to no linked list. Initializing that one, that we need to store here also in the that entry should be stored in that index. Okay, so basically we are getting that head. Bucket entry is basically a head of the linked list, and so basically what we are doing here, main HashMap entry string, that's what we are doing. Then what is the point of HashMap entry we are creating here? I think we don't need HashMap entry, this one. We can direct, because we have only one data to store. I think we don't need I will do one thing. I will HashMap entry we are not at all using here. We are not using, okay. This HashMap entry we don't need. I will delete this one because we can directly use that value. Where is the delete? Save delete. Okay. Delete anyway. Now here I will remove this one, because we in this HashMap we want to store a string, so I don't need to bother about that one. Here there is no error, no. Okay, so I created that one. Now I will add a bucket entry. Basically it's a add e. I added the element, boolean add true or false. It's a true, right? True. Whether what is it? This add have a boolean values there. Okay, I will do one thing for the. I will return this on linked list part. I will add. Yeah. Here I need to add. Okay. Yeah, here I need to do few more things to do. Check the size of the data, number of elements actually, size of the data, and if it exceeds capacity, increase the capacity. Initially we started with 16, but if it get more than 16 value, you need to increase the bucket actually. That's not required actually. The reason is that when we are using linked list, it can automatically expand as much we wanted, but the problem is that if we are using a linked list with a bucket with a linked list, basically we want constant time to access the element. But if you have a linked list with several elements, accessing constant time is not possible, because you need to go through the linked list. So because of that, we need to increase the capacity if it contains more element. The good idea is that if it is number of elements is more than capacity, then increase the capacity. That's one idea. I will do that one here. Add the element. I will explain once again. First, we need to find out the bucket index for a particular element. So hash code is a function defined in object. Many of the Java data type implemented its own hash code, like string implemented its own hash code like that. So first find out, it's basically an integer. You will get a number corresponding to that element. So we want to find out the bucket index. Bucket index should be in a particular range, because we are using as index here. We need to make sure that one it is a valid index. The one thing we know that one capacity is the size of the bucket. So use this as a modulo. Then obviously it will come 0 to capacity minus 1. So here index out of bound exception won't come. Using that one, we will get the bucket entry. If the bucket first time we are adding some element to that bucket, bucket entry will be null. So we need to initialize the bucket entry with the linked list and store the bucket index, then add it. Here we are doing size, initial size. So we can do one thing. I will define a variable here to track the number of element number of element in the bucket. So I will return size here, implemented size also. Now it's empty or not. Empty or not, you can check size is not equal to 0. Is empty, okay, is equal to 0, then it's empty. Basically we don't need that one. Can I remove this one? Anyway, I let it be here. Okay. Contains. So it contains we need to implement. Add. Yeah, that's one way we need to check. We can check whether value added or not. So what we should do for that? I will copy the add part here and enter here. The contains object E. Oh, contains, okay, contains, we should use the object here. How to do then? Okay. In our case it's E equal to O instance of E. If that is true, then use O directly. Otherwise, convert that E to. I think this is the way we need to do. Basically what I'm trying to do is that I'm checking whether instance of O, E then use O, or uh, not instance. Okay, I think I don't need to worry about its type, because assume that when we getting contains as check, we need to check O contains or not. So use that one. Or obviously hash code is available in object. So whatever type we are getting here, it will get hash code. I don't need to bother about that one. If it is string, it will use a string hash code. Then everything will work like this. And if entry is null, obviously it is return is false because element is not there. Otherwise bucket you can use contains here. Contains, okay. What is this? Okay. Okay, that's all. First we are finding the bucket index and checking the backcountry contain. That's all. Okay, we implemented both add and contains, and here we are sure operation will, it's a constant time. Even if we are using linked list, we assume that one we will have a sufficient capacity, so a capacity for that bucket, so that each element, each entry in the bucket contains only one element. Even if we are using the linked list, most of the time it will contain only one element, so you can access constant time. That's not a guarantee, but most of the time it will happen like that. So let us assume that when we implemented a constant time here. What about the contains? Contains, I think, yeah, the same thing will happen here also, because we assumes most of the time it will contain only one element in the linked list, so it also only one constant time the operation will happen. So what we need to do is that one we need to do some testing here. For that purpose, we'll create a loop, and I is equal to I less than 100, I plus plus. Here my HashMap dot add key I will checking contains. If it is not contain, I need to print that one. Contains. Then I need to print here system dot out dot print line. Not missing I, missing K plus I. Okay, we need to do that one. I will run this one and I will check. Basically I am adding 100 elements here, and adding 100 element, and I am checking whether added properly or not. Illegal start of expression, let's say should be 2 plus. Yeah, we didn't get any error. That means it's working fine, adding properly. That's what my understanding. And what else operation we need to do here? Implement the add, implement contains, size also we implemented, and remove we need to do. remove my hash. This iterator I'm not going to implement. Array also I'm not going to implement this one. This also I'm not going to implement. Yeah, remove is here. Here contains add or return or remove all clear. Clear basically we need to go to I'm not going to implement the clear. That is not a basic operation mentioned in that documentation. So here remove also we need to find out same way contains. We need to find out where it is contains, and bucket is entry means null. Otherwise bucket entry dot remove object. Now we need to do we need to check whether bucket entry is basically we are removing element from the linked list. We need to check size is 0 means we need to delete this one. Empty element and empty index means delete that entry in that bucket, because there is no element in that bucket index. You can keep in linked list, but I am deleting that one. So this is remove I will do the true. Okay, now I will do one thing here. I will go here and I will delete that also. Remove. I am going to remove that one. Basically we don't need to test anything there. Now I am checking again contains, then didn't remove. Basically what I'm doing here is that I'm deleting those one and I'm checking again. If it contains means that's an error. I'll run this one and check it. Yeah, we didn't get any error. That means remove is success. Okay, how much time it took? 43 minutes. And okay, so what else we need to do here? We implemented add with a constant time, condense with a constant time, remove with a constant time. Okay, now what I will do is that one I will do one thing. The add code part. We'll check we didn't check whether that elements contains or not. Okay, I'm simply adding even if it contains or not. That's a bad idea, because we need to check whether first let me check whether it contains. If the element is already there, If it is contains, if it is not contained only you need to add, otherwise you don't add. You need to return and you get true. Okay, if this contains, add, otherwise you don't add. What's the point of adding? It's already there. Else, no. Whenever you're adding, you need to increase the size. Size is the number of element in the HashMap set. Okay. So here what we need to do is that one we need to check beforehand if capacity is equal to size, you need to increase the bucket. If that is the case, if it is equal to size, what you need to do is that one first basically we need to increase that buckets here. It's initialized with like this. We need to expand this one. This bucket we need to here we need to find out the capacity equal to new capacity. Basically we will multiply with some numbers like 2 or 1.5, something like that. We will increase, then we will expand that bucket size. Will increase here. At the time we need to take each element and add again, because if bucket size is increasing, this bucket index will change for each element. So you can't use existing bucket index, because now it's a capacity increased, each value will change. So that we need to do here. Basically we need to take the bucket and expand it and re-add all the element. That's what you have to do. So I'm not going to implement that here, I'm just mentioning here. Okay, that's all. I think already 48 minutes and I think I am stopping there. Beyond that nothing else is here. That's once again I will explain this again. I will close this one. This is a testing code. Main, we are initializing new hash map which accepts a generic type. I passed a string. I want to store. It's not a hash map. I think we are working on hash set. I wrote a hash map. Rename hash set. I'll go here. I will change the hash set here. I didn't notice this one yet. Why that is not working here? It's a refactor. I'm not sure how to use this refactor. I think this is the rename. We should use rename. My hash set. I'm not sure how to do here. I will manually change. I will rename here also. My hash set. My hash no linked list. My hash set. Expect one argument but found 0. My hash set. Okay, okay, here is my hash set is I need to change that also. Related problem. What is that problem? My hash set. Yeah, it's running. I don't see showing here like this. I'll close and open again. Gone. Error. Yeah, fine. Okay, I will explain once again. Basically here I am defining my hash set and I want to store string, and I'm going to define my hash set. I have defined here. Basically this hash set contains a bucket of linked list of bucket, or bucket of linked list. So we need to define capacity. Default capacity I given 16, and we will initialize this array with the size 16. That's how we will store each items in that bucket. Since the bucket contains bucket is are index based, basically we need to take an element and find out index for that its bucket where we are storing. We need to find a number. Since multiple object can match to same number, we need a linked list to store in that array. That's why we defined a linked list, bucket of linked list. And yeah, it's using capacity to initialize the index. Initially I kept 16 as the size of that array. Now here adding, at the time of adding we need to check whether capacity equal to size or not. Basically we need to do that on bottom actually. Bucket entry contains E, then you don't need to do else yeah, somewhere here you need to do that one. I will right now I'll keep here only. First we need to find out the bucket index for that particular element. Hash code is defined in object, the top class, that's object, java.lang object. But many data type like a string, everything defined hash code, so you can use this hash code. Since that can be a number outside the array index, use this capacity to get that value under a valid bucket index. So we will get bucket index. Then take that bucket index which supposed to contain the linked list. If the linked list is null, that means we didn't add anything there. Then initialize that linked list and store in that bucket index. Now add that bucket index. Yeah, before adding we need to check obviously if it is a null we won't reach here actually. It can't contain, else you need to check contains or not. If it is null means obviously the item is not contained. Item doesn't contain that, so you don't need to do that one. If it is not contained, then add. If it is already contained, we don't need to do anything. That's all. Size, okay, we are increasing size. Size is basically how many elements are in that set. Bucket count is a linked list. That doesn't mean how many elements is contained, because one linked list can contain multiple elements. So we need to keep track of separately. The value we need to keep track. Otherwise, you can go to all the linked list and find out a element. That will take a linear time, not a constant time. So we will keep track of we will keep a variable, and we will keep track whenever we are adding increase. And size and empty, which means 0 means empty. Checking contains basically we need to find a bucket index and take that element out, and if the entry is there, if the entry is not bucket entry is null, that means the item is not contained. Otherwise check bucket entry dot contains. Linked list has defined this contains method. It's basically constant time. Now it's a remove. When you do the remove, yeah, we need to check whether it's contains or not. Let's check bucket entry dot contains O. Then only you need to remove, otherwise you don't need to remove, right? The size you need to decrease. That's it. And now checking bucket entry size became 0 now after removing. Then just empty that one. That's all. It's a implementation of set, and we want to implement it with constant time for the basic operations like add, remove, contains, and size. That's all. Yeah, we defined array of linked list, and yeah, linked list I used built-in, not built-in, Java class instead of defining our own linked list. I think that's enough. It's going to be 1 hour. Okay, that's all. No, nothing else I need to do. What else? It's empty iterator, size split iterator. Nothing else is there. Should I wait for 1 hour or should stop now? Okay, I will go here and I will pretend like I'm reading something here and there. I don't have anything to read here, but I want to make sure that this video is 1 hour. I'll come back here and I will look here. No, I will go here back. Note that this implementation is not synchronized. I will come back here. Now 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. Thanks for watching. I'm going to stop this video here. 53, 54, 55, 56, 57, 58, 59,